October 2022. A paper drops on arXiv titled ReAct, Synergizing Reasoning and Acting in Language Models. Yao and colleagues at Princeton and Google. 10 pages, one idea. Almost nobody outside of NLP research reads it at the time. 4 years later, that 10-page paper is the reference architecture running underneath Claude Code, Cursor, Devin, LangGraph, and roughly every agent framework you have heard of. What is in it? The whole idea is in the name. Reasoning plus acting, interleaved, in one transcript. Not reasoning first, then acting. Not acting first, then explaining, alternating. Thought, action, observation, thought, action, observation. Turns out that little pattern is worth a lot. I am Ani. Today we take the paper apart, look at what it actually claimed, and then look at a real Claude Code transcript running the same shape in 2026. Video 2 established the substrate, LLMs, specifically because of in-context learning, natural language reasoning, and structured tool call generation. The middle one, natural language reasoning, is what today's paper is fundamentally exploiting. Wei showed in 2022 that letting the model think out loud makes it more accurate. Yao asked the follow-up, what if we also let it take actions while it thinks? What if the thinking and the acting live in the same stream? That is the whole move. So the puzzle for this video. Before ReAct, agent researchers had two schools. One school said, let the model plan the whole thing first, then execute. The other school said, let the model just try actions, one at a time, and adjust. Both fail on hard tasks. Plan then execute fails because the plan gets stale after the first surprise. Try then adjust fails because the model has no memory of why it made the previous choice. Yao's move, do both at the same time and let each keep the other honest. That is the whole trick. Today's 3 beats. First, what ReAct actually claimed, reasoning only versus acting only versus interleaved, and why interleaved wins. Second, the ReAct loop as pseudocode, a tiny while loop that fits on a napkin, still under everything you use. Third, where ReAct alone falls short, and what the field added on top of it for long horizon tasks. Beat 1. What the paper actually claimed. Yao ran 3 configurations of the same base model on the same benchmark tasks. HotpotQA for question answering, ALFWorld for household simulation. Configuration 1, reasoning only, chain of thought, no tool calls. The model writes a plan, then guesses. Configuration 2, acting only. The model just emits tool calls, no reasoning trace. Configuration 3, ReAct, thought, action, observation, thought, action, observation in the same stream. Then compare accuracy. The result? ReAct wins. And it is not close. Sometimes double the accuracy of either alternative alone. And more importantly, why it wins tells you what the paper actually contributed. Reasoning only fails because the model hallucinates the state of the world. It writes in the key is under the mat when the key is not, in fact, under the mat because it never checked. Acting only fails because the model tries things without a plan, gets a confusing observation, and has no thought scratchpad to reconcile the observation with the goal. ReAct works because thought is grounded in observation, and action is grounded in thought. Each keeps the other honest. One more thing about the paper's contribution. This is not a new neural architecture. Yao did not train a new model. He just changed the prompt. Wrap the same LLM in a template that says, first write your thought, then write your action, then observe, then repeat. No new weights, no fine-tuning. The lift comes entirely from structure imposed at the prompt level, which is why this pattern spreads so fast. You could take yesterday's LLM and drop ReAct in tomorrow. Beat 2. The ReAct loop as pseudocode. Every real agent framework wraps something like this. Initialize an empty transcript. Then, in a while loop, ask the model for the next thought and action given the transcript so far. Parse out the action. Run it. That produces an observation. Append thought, action, observation to the transcript. Check if the model said done. If yes, exit. If no, loop. That is it. 15 lines of Python. Every serious agent framework of the last 4 years is a hardened, guardrailed, retry-friendly version of that. Concrete trace. You ask Claude Code, quote, find why my tests are failing on main, unquote. Thought, I should first look at what tests exist and which ones failed. Action, run the test command. Observation, 3 tests failed, all in the auth module. Thought, those look related to the token refresh change. Let me read that commit. Action, git log for auth-related commits. Observation, 1 commit yesterday changed the refresh path. Thought, read that file. Action, read the file. And on and on. Sometimes 40 of these turns per pull request. That is a ReAct transcript in 2026. Now the honest thing about production agents. The while loop from beat 1 is the skeleton. Real frameworks wrap it with parse retries when the model outputs malformed action, JSON, timeout budgets so it does not run forever, kill switches when the transcript exceeds n tokens, guardrails that check the action before running it, callbacks that let a human intervene. But under all of that instrumentation, you scroll to the middle, you find the same thought action observation transcript Yao wrote about in 2022. It did not get replaced, it got hardened. Beat 3. Where ReAct alone falls short. Long horizon tasks. If your task takes 100 tool calls to complete, the transcript grows and grows, and the model starts losing track of the earlier thoughts. It repeats itself, it retries things it already tried. It forgets the original goal. Vanilla ReAct with no additions typically breaks somewhere around 20 to 40 iterations, which is fine for a single pull request, not fine for a research project. So the field added things on top. Reflection. The model periodically stops, summarizes the transcript so far, and starts a new one from the summary. Self-critique. After each action the model asks, was that a good action, given the goal, and revises. Sub-agent decomposition. The top-level agent spawns child agents for subtasks and only stitches summaries back in. Each of those is a Lecture 3 video, but every one of them still has a ReAct loop at the bottom. So, where does that leave you in 2026? If you are building an agent, the correct default is a ReAct loop. Do not invent something fancier. Ship ReAct first, measure where it fails, then add the specific add-on that fixes your failure mode. Do not add all of them up front. That is the honest engineering advice. From the Anthropic Building Effective Agents post, and from every practitioner who has shipped an agent that made it past a demo. 3 takeaways before the quiz. 1. ReAct is a prompt-level pattern, not a new model. Interleave thought, action, and observation in the same transcript. That is the entire contribution. Roughly doubles task accuracy over reasoning only or acting only in the original paper. 2. Every real 2026 agent framework wraps a ReAct loop in production guardrails, retries, budgets, kill switches, human intervention. But scroll to the middle and you will find Yao's transcript. 3. Vanilla ReAct breaks around 20 to 40 iterations. That is where reflection, self-critique, and sub-agents come in. Coming up in Lecture 3, default to ReAct, measure, then patch. Quiz 1. What is the core contribution of the ReAct paper? A. A new transformer architecture optimized for agents. B. Interleaving thought, action, and observation in one transcript. A prompt-level pattern, no new weights. C. A benchmark for evaluating agent tool use. Or D. A new fine-tuning objective for tool use models. B. No new weights, no new training, no new benchmark. Just a prompt template that says first thought, then action, then observation, then loop. The base model is unchanged. That is the entire contribution, and that is why it deployed the same week people read the paper. Quiz 2. Why does interleaving reasoning and acting beat reasoning only, or acting only? A. Interleaved runs faster on GPUs. B. Reasoning only hallucinates the world. Acting only cannot reconcile surprises. Interleaved keeps thought grounded in observation and action grounded in thought. Mutual grounding. C. Interleaved uses less memory. Or D. The paper did not actually show that. B. The technical word is grounding. Reasoning without acting drifts because there is no external check. Acting without reasoning drifts because there is no internal check. Interleaving them makes each keep the other honest. That triangle, thought, action, observation, is the whole shape. Quiz 3. What is the honest limit of vanilla ReAct on long horizon tasks, and what did the field add on top of it? A no limits. ReAct works forever. B. Vanilla. ReAct breaks around 20 to 40 iterations from repetition, drift, goal loss. The field added reflection, self-critique, and sub-agent decomposition on top, not instead. C. ReAct was replaced entirely by supervised fine-tuning. Or D. ReAct only works with GPT models. B. Long horizon degradation is the well-known limit, and every production add-on you have heard of is layered on top of the ReAct core rather than replacing it. Reflection resets the transcript. Self-critique catches bad actions. Sub-agents decompose. All three are Lecture 3 material. All three still have a ReAct loop at the bottom. Back to the puzzle. Do AI agents actually reason? After 3 videos, we know the reasoning happens as English tokens in the thought slot of a ReAct transcript, alternating with tool calls. It is legible. You can literally read it. That does not tell us whether it is real reasoning, but it does tell us the reasoning is out in the open, not hidden inside a black box. That matters. 3 down, 27 to go. Next time, tools. The ACT step in every ReAct loop is a tool call, which means the tool has to be defined in a schema so the model knows how to call it and what to pass. We deep dive function calling, OpenAI's original design, Anthropic's tool use spec, and the open standard everyone converged on, plus the ways it fails and how to catch that. Hit subscribe.